Hello students. So today in this video we will discuss about gynoecium. Okay, what is this gynoecium? Okay, I hope you are understanding. We are discussing the detailed description of the flower. Okay, in that we have already discussed about perianth, east-vation, calyx, corolla, and also the sand tissue. And now we will discuss about gynoecium. Okay, and this gynoecium is the female sex organ of the flower, or female reproductive organ of the flower. And what we call the units are members of this gynoecium. The units or members of gynoecium are called carpels. And this carpel is equivalent to megasporophyll. Carpel is equivalent to megasporophyll. And don't forget, under androecium we discussed about the stamen, and the stamen is equivalent to microsporophyll. In the similar way, the carpel is equivalent to megasporophyll. So the stamen will produce microspores, whereas carpel will enclose megaspores inside the megasporangia. So the megasporangia are nothing but ovules or megasporangia. So the gynoecium is composed of carpels. And what are the parts you will find in a carpel? So when you take one carpel, okay, the carpel will show us three parts. The upper part is called stigma, and the lower bulbous part is called ovary, and the connection or the tubular portion that connects the stigma with ovary is called stem. So what is the function of this stigma? So the stigma will receive the pollen grains, okay, from the same flower or from other flower. So it is a receptive part of the carpel. And the ovary, which is a bulbous part or the lower part of the carpel, encloses the ovules, okay, and the style connects this stigma and ovary, and also it lifts the stigma, okay, so that it makes the pollen grains to reach the stigma very easily. So these are the three parts of the carpel. Now let us see how many carpels make a gynoecium, or how many carpels are present in a gynoecium. And this number will vary from plant to plant or from species to species. So some will have one or single carpel, okay, some will have two carpels, some will have three carpels, some will have four carpels, some will have five carpels, and some will have more than five carpels. So based on that, the gynoecium is described. That means we use one technical term here. Okay, when the gynoecium is with one carpel, it is called monocarpellary gynoecium. And the example is Fabaceae. In the Fabaceae family, okay, you will find monocarpellary gynoecium. Means what? In that flower, the gynoecium is with single carpel. Not only that, the academically very important family, Poaceae, a monocot family. In that also you will find monocarpellary gynoecium. And when there are two carpels, the gynoecium is described as bicarpellary gynoecium, and the example is Solanaceae. And when three carpels are present, it is described as tricarpellary gynoecium, and the example is Liliaceae family. And when there are 4 carpels, so the gynoecium is described as tetracarpellary gynoecium, and the example is Enothera lamarckiana, that is evening primrose. And when there are 5 carpels, the gynoecium is described as pentacarpellary gynoecium. The example is China rose. We are familiar with that. And when it is more than 5, so it is described as multicarpellary gynoecium, and we find this in citrus and also in cucurbits or pumpkin, like pumpkin. Cucurbits means all the members that belong to the family Cucurbitaceae are called cucurbits. Like what? All gourds means what? Bitter gourd, angular gourd, okay, snake gourd, bottle gourd. I think you heard about these gourds. And also pumpkin, cucumber, all of them, they belong to this family, okay, Cucurbitaceae, and hence they're all called as what? Cucurbits. In all of them, the gynoecium is multicarpellary gynoecium. And now we will discuss how these when there is one carpel, naturally it is free. But when the gynoecium is made up of two to many carpels, these two to many carpels, how they are present? Are they present freely in the flower? Are present fused within the flower? That we have to discuss now. Okay. So now let's see the condition of the carpels, and these carpels may be free or they may be fused. And when they are free, we call the gynoecium as Hippocampus gynoecium. Hippocampus gynoecium. And when they are fused, we call that as what? Syncarpus gynoecium. Okay, and the Hippocampus gynoecium examples are Michaelia, Magnolia, Michaelia, Annona, Neelambo, that is lotus. So here I drew one diagram, and you can see each one here is a carpel. So all carpels are freely present over that thalamus. Okay, we have taken only that gynoecium part of the flower. So the carpels are free here. So we have to remember that every carpel will show the stigma, style, and ovary. Okay, and that's why remember only that this ovary after fertilization will become fruits, no? So from this flower, as there are many ovaries, because the number of ovaries here is equal to number of carpels. That's why from one flower you will get what? A aggregate fruit, or a cluster of fruitlets, which is called aggregate fruits. So Annona I wrote, that is what? Custard apple. So custard apple looks like a single fruit, but actually it is aggregate fruit. Okay, it is composed of many fruitlets, which are berries. Okay, like that Hippocampus gynoecium, and when we come to the Syncarpus gynoecium, and the Syncarpus gynoecium may be developed from bicarpellary, tricarpellary, tetracarpellary, pentacarpellary, or multicarpellary. But as all stigmas, styles, and ovaries are fused, you will find in that Syncarpus gynoecium one stigma, one style, and one ovary. I hope you are understanding this point. If it is Hippocampus gynoecium, you will find many ovaries, many stales, many stigmas, as the number is equal to number of carpels. That's why we got, when after federation we are getting aggregate fruit here, but this one develops into a simple fruit. Means you will get only, as there is only one ovary, you get one fruit. Okay, so that you will find in Solanaceae family, that is bicarpellary syncarpus, and in Liliaceae it is tricarpellary syncarpus gynoecium. Okay, that is the condition of the gynoecium. That is based on the condition of the carpels, whether they are free or fused. If they are free, we call the gynoecium as Hippocampus gynoecium, and when they are fused, we call the gynoecium as syncarpus gynoecium. Okay. Now we will discuss about the most important part of the carpel or the gynoecium, that is the bulbous portion, that is ovary. So the bulbous portion of the gynoecium is ovary, and inside the ovary you will find some chambers, and these chambers are called locules. And in those locules you will find these ovules, and the number of ovules will vary from plant to plant or from species to species. And in some ovaries you will find one seed, and in some ovaries you will find one ovule, and in some you will find many ovules. So whenever the ovary develops into a fruit, so in some fruits you will find a single seed, because their ovary contained only one ovule, and in some fruits you will find many seeds, that indicates that their ovary contained many ovules. Okay, and now how many locules are present in the ovary? How many chambers are present? Generally, that number is equal to number of carpels. Is what based on that, generally we describe like this. When it is monocarpellary, then there will be one locule, so it is called unilocular. Bicarpellary, bilocular. Tricarpellary, trilocular. Tetracarpellary, tetralocular. Pentacarpellary, pentalocular. Multicarpellary, multilocular. And the same examples we can take from here, like what monocarpellary, unilocular, you will find in Fabaceae and Poaceae. Bicarpellary, bilocular, you will find in Solanaceae. Trilocular in Liliaceae. I hope you are understanding. I am bringing the same examples here. And the tetralocular, there is tetracarpellary, tetralocular, Enothera. Pentacarpellary, pentalocular, China rose. and multicarpellary multilocular citrus. But I am not taking that cucurbits. Okay, why? Because here we find some exceptions. Okay. So what are those exceptions? And sometimes you find bicarpellary. There will be two carpels, but a single locule may be there. Then it becomes what, unilocular. And bicarpellary unilocular example. Okay, we can take sunflower. But here, okay, I will draw one diagram. It will be like this. This is one carpel in the transverse section, and this is another carpel. And every carpel will have two sutures, and this is what, dorsal suture. Dorsal suture of one carpel of let us say 1, and this is dorsal suture of second carpel. And these two are margins of first carpel, and these are the margins of second carpel, and the margins are fused, and they make the ventral suture. Ventral suture. So ventral sutures are formed by the fusion of two different carpels, here and here. This is ventral suture, and generally that okay, cushion-like tissue will develop here that produces ovules and is called placenta. So now you can see how many chambers are there because of this fusion. Though there are two carpels, but there is a single locule inside. That's why it is called bicarpellary unilocular. And remember, after we have to take one example of Brassicaceae family. Brassicaceae family, and Brassica, that is mustard, is an example of this Brassicaceae family. And in that, while this ovary is developing, one septum will develop, and this septum once develops, septum means the wall when it develops. Okay, so now the unilocular will become bilocular. So now we see, and the septum is called replum. So replum is a false septum. So remember, in Brassicaceae, that's why when we describe about the ovary, we describe it like this. It is bicarpellary unilocular, later becomes bilocular due to formation of false septum called replum. Okay, so that is one example, and one more example you can take: bicarpellary tetralocular. Tetralocular. And this condition you will find in the plant Datura of Solanaceae family. And one more example you can take like tricarpellary unilocular. And as I told you, cucurbits will not show, though they are multicarpellary. Okay, they will show what this unilocular condition. Okay, you just remember that it is not multicarpillary, it is tricarpillary unilocular. That is in Hippocampus. Okay, so like that, these are the different examples for. So I hope you are understanding. Generally, the number of locules is equal to number of carpels, but some exceptions which we discussed now like this. Okay. So now let us discuss the last aspect in the gyration, that is placentation. What is this placentation? So the arrangement of vovules, the arrangement of vovules on the placenta inside the ovary. Inside the ovary is called placentation, and it is of different types. And let us discuss these 5 types of placentations. One is marginal placentation, and this marginal placentation generally encountered in monocarpellary unilocular gyration or monocarpellary gyration with unilocular ovary with single chamber. And here you find what the 2 ventral sutures will fuse, and this is ventral suture and this is dorsal suture, and the ventral suture is formed by the fusion of 2 margins of single carpel, and now on the inner side the placenta will develop, and from that placenta the ovules will develop. And of course, remember this is the characteristic feature of the family Fabaceae, or you can take that bean as an example, or you can take the Pisum sativum, garden pea, which is an example. And generally, when we want to open, so generally we remove the fiber here and we open it like this. And you see, I am opening it. And when you open the fruit, okay, you will find the ovules attached on the 2 margins. Of course, when you close it, okay, so one ventral suture is formed. That means one margin is formed. That's why this is called marginal placentation. So the example for this is Fabaceae. And now let us see the parietal placentation. And this parietal placentation may be seen among the gynoecium with 2 carpels, bicarpellary gynoecium. And okay, the example, okay, brassica, that is mustard, and in that this is one carpel and this is another carpel, and this is the dorsal suture of first carpel, and this is dorsal suture of second carpel, and this is ventral suture, and this is another ventral suture. So it is bicarpellary unilocular, and the placenta or that cushion-like tissue will develop on the ventral sutures and will produce the ovules. So now these ovules appear as if they developed on the wall of the ovary, that is inner wall of the ovary or inner side wall of the ovary. It is called parietal placentation. Means parietal itself means what? Wall. So parietal placentation. But I want to tell you one more thing. We discussed that point, and later one false wall develops, and which is called what? Raclum. That is false septum. So bicarpellary gynoecium with unilocular ovary later becomes bilocular due to formation of this false septum. Okay, and one more example for parietal presentation is cucurbits or pumpkin. Okay, there the gynoecium is tricarpellary, and let me say this is the dorsal suture of first carpel, dorsal suture of second carpel, and this is dorsal suture of third carpel. 1, 2, 3. But you can see the margins, they are fused only at the margins, and because of which we are finding only one locule. So it is tricarpellary unilocular. Tricarpellary unilocular. And now the ovules will develop on the walls. Exactly at what sutures? Ventral sutures. So this is also an example for parietal presentation. So the example for this is what? Cucurbits. Okay. Now let us discuss about the third type, axial presentation. And this axial presentation you will find in bicarpellary or tricarpellary or tetracarpellary or pentacarpellary or multicarpellary. Okay, and one condition that we have to see here, when this number of locules is equal to number of carpels, then the type of presentation will be axial presentation. Like this, I hope you are understanding. Bicarpellary, bilocular, tricarpellary, trilocular, tetracarpellary, tetralocular, pentacarpellary, pentalocular, multicarpellary, multilocular. So when the number of carpels is equal to number of locules, the type of presentation will be axial presentation. And let us see the first one. You see here, this is bicarpellary, bilocular. So as a result of which the ventral sutures are merged here, and they are making one axis, and the ovules will develop here on this axis. So this is called axial presentation, and this you will find in Solanaceae. And suppose if you take Liliaceae, you can see it is tricarpellary, trilocular, and the ovules will develop here, and all ventral sutures formed one axis. That's why it is called axial presentation. Tetralocular, of course, Enothera lamarckiana, but that will show another type, because initially it is axial presentation, but later becomes precentral. That we will discuss in the next one. And pentalocular will be like this. Okay, pentacarpellary, pentalocular, and axis is formed, and the ovules will be like this. So there is what the example is China rose, and for tricarpillary liliaceae, already I told you, and for multicarpillary the example is what citrus. That is what axial placentation. And now let us see this fourth type, free central placentation. Free central placentation. This is what the example for free central placentation is dianthus free central plus placentation. Dianthus, which is commonly called as pink flower plant, and Enothera, there is plain rose. What was to see here? Actually, it is multicarpillary, multilocular with the axial placentation. So I am showing a diagrammatic representation of this. 1, 2, 3, 4, 5, 6. So multicarpillary. And these are all locules, and they are separated by the septa, and during course of time or during course of development, the septa will degenerate, and as a result of which you will find all the ovules remain attached freely to the central axis. So this is in the beginning and this is after development. So now this is called free central placentation. And now let us say the basal placentation, very simple, and you will find this basal placentation in the gynoecium of sunflower, and this is gynoecium of sunflower, and you will find a single ovule attached at the base. Single ovule attached at the base. So this is called basal placentation. So these are the different types of placentations, and with that we have completed this topic, flower.